So let's look at solving an absolute value inequality. So here's a simple one. Absolute value of x minus 2 less than or equal to 5. So first thing we always have to do is first make it an equation. So we're going to make it an equation, and this is going to become the absolute value of x minus 2 equal to 5. So we're going to have x minus 2 equals 5. So that means that x equals 7. Oh, tough math there. So now let's look at the other one. We're going to have the negative of x minus 2 equals 5. So does negative x plus 2 equal 5? So we're going to have negative x equals 3. X equals negative 3. So those are our two boundary points. We take our number line, and we're going to say that negative 3 is right here. And we're going to say that 7 is right here. And these are going to be boundary points. Now we know that it can equal at that point because the inequality is less than or equal to. So we're going to put closed dots on that number line. So now all we have to do is test the regions. So let's test negative 4, let's test 0, and let's test 8. So we're going to test negative 4 in the original inequality. Is negative 4 minus 2 in absolute values less than or equal to 5? So is the absolute value of negative 6 less than or equal to 5? Well, is 6 less than or equal to 5? And that is definitely an NO. That's not true. 6 is greater than 5. So it's not going to be true if we are less than negative 3. So let's test 0. So we are going to say 0 minus 2 absolute value. Is that less than or equal to 5? Well, is the absolute value of negative 2 less than or equal to 5? Well, is 2 less than or equal to 5? And that is, of course, a yes. So we're going to include all of the points in between negative 3 and 7. And again, we can't make any assumptions beyond these boundary points, so we have to check 8. So let's go 8 minus 2 is less than or equal to 5. And hopefully by the time you've written it down, you've realized that we have the absolute value of 6. Is that less than or equal to 5? 6 is not less than or equal to 5, so that's a no. So our solution here, and we write our solution as an inequality, is negative 3 is less than or equal to x, which is less than or equal to 7. There's our solution to our inequality. So let's look at one more example. Now, in this example, we have a double inequality. Well, we do the exact same thing as we did before. Well, first of all, we have to make an equation. So let's take our inequality that never changes. X plus 3 is equal to the absolute value of x minus 4. And again, what we have to do is we have to consider the positive and negative of both terms. So let's look at x plus 3 is equal to x minus 4. And that's where we consider that both of these brackets are positive. So let's keep the first one the same, x plus 3, and let's make this the negative x minus 4, and this time we're going to make this one negative. Now, if we recognize here two negatives right here are the same as two positives. So this equation and this equation are the exact same. And this equation and this equation are actually the exact same too, because we could just multiply everything by a negative and get both of these equations the same. So what happens here is we only have to consider the first equation and the second equation. So using that, let's solve the first one. And I'll go back to our black pen here. X plus 3 is equal to x minus 4. So now we're going to get 0x equals negative 7. Now this makes no sense at all. So if we get something that makes no sense at all, then we don't even consider it. That's one of those roots that we're not even going to consider because it doesn't give you anything, so this is going to give you absolutely nothing. So it's starting to get even easier because we're just going to have to consider x plus 3 is equal to negative x minus 4. So we're going to have x plus 3 is equal to negative x plus 4. So we're going to have 2x is equal to 1, divide both sides by 2, and the only possible solution for our number line in this particular case is if x equals 1/2. So let's call this 0, and let's say this is 1/2. It's not going to be equal to, because the inequality is not equal to, so there's going to be an open dot, and we're just going to test points on either side. So let's test x equals 0, and let's test x equals 1. So we're going to have the absolute value of x plus 3, I'm just going to rewrite the equation, is less than the absolute value of x minus 4. So when we test x equals 0, we're going to get 3. Is that less than or equal to negative 4? Well, is 3 less than 4? Definitely is. So we're going to say, let's check, that was x equals 0, let's check x equals 1. So we're going to have 1 plus 3. Is that less than or equal, or less than 1 minus 4? Well, is the absolute value of 4 less than negative 3? Well, 4 is not less than 3, so that's a big no. So the only one that works is if we are less than 1/2. So our solution to this case is x is less than 1/2. Only one solution in this particular case. So that's how we solve absolute value inequalities.